Hello and welcome to the section 5 of SAS programming course. In this section, we talk about data management. And there are two main tools for data management in SAS programming, and these are DataStep and ProcSQL. In this course, we focus on DataStep, but also ProcSQL is very good tool. It can be even more efficient than DataStep, and it's often easier way to data management for people who have SQL background already before coming to SAS. But then on the other hand, DataStep is the more traditional way to do data management in SAS, and it has its own strengths as well. In the data step, you can take existing SAS dataset as input data by using the set statement. We actually already had some example about that in earlier sections. But when you are doing this, you have to be careful and don't delete your original data. So here I have an example which is a bad idea. So if you have in the set statement kir.old data and the same one in the data statement kir.old data, then you would be taking as the input data your old data and replacing it with the modified version with probably some other programming statements here in the data step. So I think it's much better idea to keep your input data and output data separate. So you take in the set statement the old data as input data, and you don't replace it. You keep it, but create a new version. It can be in the same folder because we have the same library reference here, but you give a new name to the resulting new data set. Then we go into different data management operations. First, we talk about variable transformations. We can use various arithmetic operations using this simple expression. So we can add this into the data step so that on the left side we have the name of the resulting variable, then we have equal sign, and on the right hand side we have some arithmetic expression that will create the new or the values to the new variable. And we of course always end the statement with the semicolon. And the resulting variable can either be an existing variable or a new one. So we can replace an existing variable if we like. Here we have two examples of these kind of statements. In the first one, we create a variable called profit so that we take value from income and subtract value from expenses. And the result of this calculation will be the value of profit for each row in our data set. And another one is so that we divide profit by income and multiply it with 1000 to get the profit percentage. Then just a little sidestep here. Traditionally, when we do SAS programming, we have had the use to use proc print to output or to see the output or the resulting data set. And here is the basic syntax for that we type proc print, and then in the data option we give the name of the input data, and that would print us the how the input data looks like. But the modern user interface is SAS Studio. We don't really need to use this as much anymore because when we run some code, we usually can just click open the output data and see it in the SAS Studio more easily. It's also good to notice a few differences between the proc step and the data step. So in the proc step, you identify the input data in this data option, as we saw in this example. Some procs also create output data as the result. So usually there is out option in the same proc statement where you can identify the output data. And that's the typical structure in these procs or proc steps. But as we saw earlier in the data step, it's a little bit different order. So you specify the name of the output data actually on the first line in the data statement, and you use the set statement to specify the name of the input data. So these are a little bit different and might cause some confusion when you first start with SAS programming. So you can then come back here and check how it was. Then we continue with the expressions that we saw earlier. Sometimes these variable transformations are targeted only for some specific data rows. You don't want to do it for all the rows, and this can be done using the if then else structure. So in this example that we see here, we are basically doing the same thing that we want to do some arithmetic operation to modify the values of expenses. So we want to add 500 to expenses, but we only want to do that if the farm type equals this anim. So if the value of the farm type variable is anim, then we add 500 to expenses. But actually for all the other farm types, we want to add 1000 to expenses. So here we start with if farm type equals anim, then we do this, but else we do this. Another way to do this thing would be to specify each type value separately. We could have a separate if statement for type equals anim, type equals crop, and type equals other, which are the three values that are possible for this type. And then we would have them specified here separately. But these two, they do the same end result. When you are using these if statements, you can combine several conditions using and or operators. So here we have an example where we are saying that if year equals 1999 or year equals 2002 or year equals 2004, then we do something. So for all of these 3 years, we do the same thing. And the same thing could be done using this in operator just as well, that if year in and then within the parentheses, we could list the values that are okay to meet the condition. And then we specify what to do for those rows that meet this condition. And sometimes we need to use parentheses also here, for example, that if we want to specify some specific combinations of conditions, so we could say that year is larger than 99 and location is Mietoinen, or alternatively year is larger than 86 and location is Jokioinen, then we do something. So remember this as well. Then we can also use functions to perform these transformations. SAS has hundreds of functions ready for us that we can use in the data step. One example here is the log, which is the natural logarithm function. So here we would subtract expenses from income, and for that result, we take the natural logarithm and save it in the variable called L underscore profit. The handling of missing values in transformation is also something to keep in mind. You need to be careful with functions for one, because, for example, sum function calculates the sum even if one of the items being added is missing. So basically, the main idea is that functions just leave the missing values aside, and they perform what they are doing among the other values that are non-missing. But on the other hand, if you have missing values in arithmetic operations, they give you a missing value as an end result if some of the values are missing. So here is an example. We do basically the same thing either by using a function or by using arithmetic operations. So we have 5 variables from A1 to A5, and we calculate the sum either with a sum function here or just having a plus sign between the variable names using the arithmetic operation. And we have two data rows. In the first row, we have 1, 2, 3, 4, and missing value for A1 through A5. And in the other data line, we have 1 through 5 for each line. And here we see that here are the first ones here are the observation numbers. So these are the values 1, 2, 3, 4, and missing 1, 2, 3, 4, and 5. If you calculate the sum using if we calculate the sum using the sum function, we get 10 for the first. For these 1, 2, 3, 1 plus 2 plus 3 plus 4 plus missing value, that will equal 10. But if we use the arithmetic operation, we get the missing value as an end result. So there is a difference whether you calculate the sum using the function or the arithmetic operations. But when we do not have any missing values, then we get the same 15 for both, so we can use either way. Yeah.